Okay, here is the last new material, the last section. It is section 9.4 of your textbook, which you have access to on my math lab, don't forget. And it is on series. So we know what a sequence is. When you add up a certain group of those terms, then you have what is called a series. So here is a sequence, 4, 6, 8. I hope you recognize that this is arithmetic. You just keep on adding 2 to get the next term. That is a sequence. A sequence is just a listing of numbers. So notice the commas. If you add up three numbers, 4, 6, 8, you get 18. Now suddenly it is a series. And this specific example, it's just a series of A1, A2, and A3. You can add up any amount of range values in this sequence. You can add them all up. You can add up one or two, but if you're adding them up, it's called a series. And this Greek letter, sigma, is capital S for Greeks. And in math, we use this as an operator, and it tells us to add. It tells us to add things, in our case, add things of a sequence. And so we start right here with n equals 1. So we start with the first term, and we add every term after that until we add the third term. So this sequence, 4, 6, 8, notice it has a common difference of 2, and the first term is 4. So I hope you recognize this, a1 plus the common difference times n minus 1. And then if you clean this up a little bit, distribute that 2, you get this. So this right here, this value is 18. This is how old you have to be to vote in our country. But when you see this, I want you to kind of practice seeing it as a sum. You need to add something. And let's just do this very quickly. We start when n is 1. Well, if n is 1, oh, where's my cursor? If n is 1, then 2 times 1 plus 2 is 4. That's the first term. And then I do the second term, so 2 times 2 plus 2. So you see all I'm doing is replacing n with 1, and then I replace n with 2, and then I replace n with 3, from 1 all the way to 3. And then I add them up. This is 4 plus 2, which is 6. And then 2 times 3 plus 2 is 8. So what I've got is this equals 4 plus 6 plus 8, which gives me my 18. So let's practice. You should pause the video, please, and tell me the values of these three. I'm especially interested in how you handle this one. But pause the video and try to evaluate them, please. So I very much hope you did. First of all, this is sigma, but it's not n, it's k. That shouldn't really bother us. We can replace n with any letter we want, and k is a popular letter. So here, this is a arithmetic sequence. And now, if it can be written as a line, as an arithmetic sequence where the common difference is 3. But I want to add the first term plus the second term plus the third term plus the fourth term plus the fifth term. I add up those 5 terms. So let's show my work like a good boy. I hope you're doing that when you do your test and quiz. So 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. And that equals 3 plus 6 plus 9 plus 12 plus 15. And that equals 9 plus 9 is 18 plus 12 is 30 plus 15 is 45. So this equals 45. Now, if you have an Inspire, good for you because it's a great calculator. The 84 can do what I'm about to do, but it's much more it's clunkier. You'll just please do a YouTube search or a Google search on how to do it on the 84. But with the Inspire, it's usually easier. And if you click on this shorthand right by the 9, you'll see a sigma right here. So we just need to type in some stuff. K equals 1. It went all the way to 5, and it was evaluating 3K. Press enter, and it does it for you. But that's if you're faced with this on a test and you give me this, you're making my job really easy. You're also breaking my heart because I'm going to give you a 0. This is not showing work. So you gotta show that work that I did right here. What did you get for this? I was curious here because there are a couple of things that are different. One, you're starting with the third term, and you're adding the fourth term plus the fifth term plus the sixth term. And then how did you handle this negative? This negative is not being squared. Only the n is being squared. So you are adding 4 negative numbers here, starting with, excuse me, starting with -9 plus -16. So 3 squared is 9, of course, but then it's -9. 4 squared is 16, but there's a negative in front, so it's -16. I'm not squaring -4. I'm squaring 4 and then multiplying it by -1. And then plus -1 times 5 squared, which is -25, plus -1 times 6 squared, which is that. This -9 and -16 make -25, plus another -25 is -50, plus -36 is -86, which if you work in a restaurant, you know exactly what the number 86 means. And then this one, oh my goodness. You start with the first term, and then you add the second term, and then you add the third term forever, ad infinitum. What are you doing here? So what did you get for this? Well, this is a number that we recognize, actually. Let me get a different program up here. So I got 3 divided by 10 to the first, plus 3 divided by 10 to the second, which is 3/100ths, plus 3 divided by 10 to the third, plus 3 divided by 10 to the fourth, and on and on and on and on we go. Well, I hope you didn't get a common denominator and then start adding all those things up. Because 3 to the 10th, I'm sorry, 3 divided by 10 is 3/10, which is 0.3. 3/10 is 0.3. And 3/100ths is 0.03. And 3/1000ths is 0.003. And 3/10,000ths is 0.0003. And on you go. Well, can you see that when you add these up, you get 0.33333 repeating, which is 1/3. So 1/3, hopefully this is kind of interesting you, but the number 1/3 is, we all know it's 0.3 repeating, but you can write it as the sum of an infinite amount of numbers. So if you ever want to lose friends or win some money on a bet, you can approach someone and say, I bet you I can add an infinite amount of numbers, all positive, and still get an answer under 1. And most people would say that's impossible, but you could just say, well, 3/10 plus 3/100ths plus 3/1000ths plus etc. equals just 0.33333, and that's just 1/3. So pay up. Last slide. If you're a math fan, this is your first idol. This guy, this is Carl Friedrich Gauss, and he's amazing. He's a super smart, crazy genius. Every mathematician reveres him. He is your first fan if you like math, and then after that you can kind of pick somebody else. But if you want, he's the Michael Jordan of math. And there's this famous story about him, which you should kind of be aware of in case you want to lose more friends. When he was in grade school, his teacher wanted to buy some time to do something, and so he gave his students a task. He said, add up the first 100 positive integers. And so everybody diligently went to their work and did 1 plus 2 plus 3 plus 4, and they had to go all the way to 100. It would take even decent math students a few minutes to do this. It would take them more than a few minutes, especially with no calculators. But within about a minute or so, Gauss had, not only was he done, but he had the right answer. So this is what he did. This is really nice. He knows that he has to add all these numbers, which, how does this relate to what we're doing right now? 1, 2, 3, 4, 5, 6, 7, 8. That's a sequence, isn't it? That's an arithmetic sequence. And if I add all these up, then I've suddenly got a series. So he recognized that 1 plus 2 plus 3, you can just write it all out in one line. And then this is the creative part, he recognized he did this. That doesn't seem like much at first. All he did was just reverse the order, okay? But hang on to that for a second. If you add up all of these numbers, it's going to equal something. So let's just call it S. S for sum. And if you rearrange, if you completely reverse the order in which you add these numbers, you're still going to get the same sum, aren't you? I mean, I could still call it S. But his incredible insight, and he probably just saw this many, many steps ahead before even writing it down, was that he realized you could add these up. And now take a second to see the significance of adding these two equations. You would take 1 plus 100 and get 101. Then you would take 2 plus 99 and get 101. Then you would take 3 plus 98 and get 101. 4 plus 97 is 101. And this continues all the way down the line until you get 98 plus 3, which is 101, plus 99 plus 2. You get the idea. Now, what does that equal? What does that equal? That equals S plus S, which is 2S. Well, what do we have here? We've got a bunch of 101s, but how many 101s do we have? How many 101s do we have? We've got 100 101s, don't we? We added 100 numbers, so that was 100 101s. And now 100 times 101 equals twice the sum that the teacher wanted to find out. So divide both sides by 2, and you get 50 101s. And multiply 50 by 101, and you get 5,050, and you're done. And that is the correct answer. If you take 1 plus 2 plus 3 all the way to plus 100, you will get 5,050. And that 9 or 10-year-old Gauss figured that out. Who knows if that story is true, but if it's going to be true for anybody, it would be true for this guy. And that's where we're going to leave it right here, because this will come into play later on. We can actually use this idea to add any amount of an arithmetic sequence.